Hey, this is Gary Mitchell. I'm back for another one of my infrequent but often interesting podcasts. And this is an unusual treat because I almost never have a guest, and there are reasons for it that we won't go into. But uh, but today I do have a guest from a company called RoviSys, and Bryan DeBois will explain more about that later. But as always, I'd like to stop and recognize my sponsor, Inductive Automation. In inductive automation, and we've been talking about Ignition and their latest Ignition product, Ignition 8.3. But this is crazy. I can't keep up with the advancements they've made ever since September when I first heard about this at the Ignition Community Conference. And by the way, quick plug, Ignition Community Conference, you can get your reservations and everything. It's all open and ready to go this coming September in Sacramento. But anyway, check out Ignition. There's an awful lot to check out. Go to inductiveautomation.com. Check out Ignition and all that it has, and they keep increasing, improving and setting up new parts all the time. Can't keep up with it, to be honest. And it's still my favorite. I've been in software since 1977. Anyway, a long time, and I appreciate their sponsorship of this podcast and my website, themanufacturingconnection.com. So today, interestingly enough, we set this meeting up, this interview some time ago, and I didn't realize I was going to automate the trade show conference in Chicago, and we're recording this on Friday, and on Monday, I'm taking the train into town, and my inbox has been flooded the last 3 weeks at least with news from the show. It used to be such a small show, and now they have 1,000 exhibitors. It's really huge, and every one of them wants to talk about AI, what they're doing with AI, and all that. Uh, Either they help you with AI, or they'll do AI, or something like that. So it's kind of like all about AI, and sometimes I get a little bit jaundiced about hearing the words too often. But interestingly enough, we have Bryan here with us from RoviSys, and the reason why they contacted me and I said, "Oh yeah, let's talk." He's the director of industrial AI at RoviSys, and RoviSys is a large independent system integrator. But Bryan, why don't you tell us what you're doing there and who the heck RoviSys is anyway?
For sure. And thanks for having me on, Gary. So RoviSys is as you mentioned, an independent system integrator, and we are an OT system integrator. So we are focused on those industrial and manufacturing customers pretty much exclusively. Now, that being said, we work across 15 different industries. So everything from life sciences to oil and gas to chem, CPG, right on down the line. So broad from that perspective, but the one focus area is they are all manufacturing and industrial customers. And we've been around since 1989. So the company's been around now for what, 37 years. I started in the year 2000 at RoviSys, so I've actually been here for 26 of those years. And started out, I had a computer science background from the University of Akron, and came in and worked primarily, if your audience is familiar with the ISA 95 standard, worked primarily in that level 3 space. So that's that information solution space. It's above the plant floor, but it's or above the controls layer, I should say, but it's below like the ERP and the level 4 financial systems. And in that level 3 space, that's where you would typically see things like MES, manufacturing execution system implementations. That's where you would see historian implementations. And so I was building software around all of that, and this is in the early 2000s, where you couldn't just go out and buy an MES off the shelf. So we were building a lot of custom MESs for customers. We were building systems on top of their historians. We were, of course, integrating systems, writing the software to kind of glue all this data together. And then I kind of moved up through the organization. And then in 2019, we hit our 30-year anniversary at RoviSys, and we said, what's next? And so at that point, we started 3 centers of excellence in 2019. One was industrial networking, because we saw the boom and people focusing on the cybersecurity around the plant floor. The second one was MES. So we actually have a whole division that just does MES implementations all day, every day. And then the third one was my division, and that's industrial AI. So we started this division actually 7 years ago, well before the launch of ChatGPT, and of course then the boom of the new boom of AI. I think a lot of people sometimes feel like AI started in November of 2022 when ChatGPT launched. Of course, being a student of computer science, I studied AI when I was in college, so I know that AI goes back to the 60s and maybe even before. But a lot of people are focused on the AI that exists today, and we can get into kind of the distinctions between the different types of AI. But the AI that exists today, the LLMs, and that's all called generative AI. That's your image and video generation. That's your LLMs. That's your ChatGPTs and your Groks. Those are all under the umbrella of generative AI, which is an important type of AI, but it's not the only kind of AI. And in fact, on the plant floor, there are other types of AI that are actually more important and that we've been using for decades, well before generative AI, kind of came on the scene.
Very interesting. I lost a programmer who worked for me in 1989, and he decided he was going to quit and go back to school because he had a lot of money uh, to study AI. And
Yeah.
people talk to me about how new it is, and I'm going, well, I think I took my first class on neural networking for motion control in the early 90s. So
Yep.
yeah, it has been around, and which is why I usually like to press for definitions an awful lot. But I suppose I could mention I used to be on the MESA, the MES Association Technical Committee for quite a few years.
Yeah.
That was my first software was so I guess our career is kind of like I mean I started 25 years before you, but anyway, they kind of overlap, and it's an important that's an important area of the enterprise. But you're right, the MES area has been so amorphous because it includes so many different kinds of things,
Hmm.
and it's software and it's connecting and it's tying things together and it's executing. So you're telling the factory or the people what to execute, how to execute, when to execute, all those kind of things. That's an important layer, but it's always been to me confusing, even though I've been in it. Your company took a look, rightly so, and said, "Hey, AI is a big thing." So why don't we delve a little bit into, well, what did you expect? What do you expect as an integrator? Is there product integration along with that, or is it software integration?
Yeah.
Just what did you expect to put together as you put together this team and this division?
Well, I mean, if you rewind to 2019, again, like I will say that I didn't expect it to be as frankly, I didn't expect it to be as well adopted already within the industry as it was. So in 2019, I was very nervous that are we a little too early to the party? Are people even talking about AI? Are people doing things with that? And I remember I went to, as a glass customer, I went to one of my first meetings with a customer, and you learn more from those customer meetings. That doesn't matter. All the planning and boardrooms doesn't matter. The only thing that matters is when you sit down with a customer and you have those conversations. And I was talking to them about AI, and they go, "Oh yeah, we're doing some AI. We just hired a couple data scientists." And so that to me confirmed that, okay, maybe we're not really ahead on this. Maybe this is the right time to kind of strike. And one of the things that we felt like, as an established OT system integrator who knew the plant floor well, we felt like we were in the right position to operationalize AI. So in conversations with customers, we would find out that, yeah, we've got a small data science team, and look, they've come up with some innovations and maybe some machine learning models based on the data from the plant floor, but nobody knows how to operationalize that. Nobody knows how to get that running in a plant that has to run 24/7. And then, importantly, organizational change management that it takes to get an operator, a supervisor, to, you're basically saying, forget everything, all the
Yeah.
instincts you've built over decades of operating this equipment, and now put all your trust in this ML model. So, that's a big sell sometimes. So we felt like, look, we've been successful at implementing technology on the plant floor for decades. We felt like we were in a good position to go ahead and and bring those capabilities to the plant floor around AI. So that was kind of a surprise. One of the other things that was interesting was, the presidents of my company at the time, they sat me down and they said, okay, what kind of team do you need? Do you need to hire specialists? Do we need to go out in the market and hire AI specialists and experts and data science experts? And I said, you know what? We've never done that in the past here at RoviSys. We really hire what we consider generalists. And then we kind of we embed them in manufacturing and we teach them, because that's the part that's the hard part, right? You can take a specialist, someone who knows data science inside and out, but then it's harder in some ways to teach them manufacturing, to teach them how high the stakes are down on the plant floor, to teach them what it means. Like, you kind of have to live that. And so we've never done it that way. We've never hired a specialist and tried to train them on the plant floor. I said, let's take our existing plant floor experts, the folks, these engineers who have worked day in and day out in these plants, and I think that we can get them up to speed on the technology, on the AI. We've always done it that way in the past. And I think that we'll be successful doing that. And I said, and here's the other thing. This was 2019. I said, I have a feeling that the folks coming out of the colleges over the next 5 to 10 years, we're going to start to see data science minors. We're going to start to see data science double majors. So we're going to get that expertise anyway, organically, without having to go out and just hire it in. So that's what we ended up doing, and it ended up working out really well. So I've got a great team that now are both experts on the plant floor, but then also experts on the data science and on the AI, and that's worked out really well for us. Now, one of the other things that I'll say that was interesting, that was kind of a surprise, was as I talked about the different types of AI. So I really put them into kind of three categories. And some of this should sound very familiar to you. So the first category is the traditional AI. So it's going to be your analytical and your predictive models. These are models that have been around for decades, right? You could almost put model predictive control in that category. I mean, these are, and what's funny is people talk about AI until it's just commonplace, and then it's not AI anymore, right? AI is basically just this term for whatever is the new technology, the new intelligence. But then once it starts to become integrated into everything, nobody really refers to it as AI anymore. Oh, that's just MPC. MPC's been around for 20 years. Well, at the time, it was pretty revolutionary when it came out, but now so that first category, the traditional AI, those are your analytical and predictive models that have been around for a long time. Things like anomaly detection. This is not necessarily new in our industry. It's been around, it's been proven. Computer vision, again, not necessarily new in our industry, but there's still a lot of customers that are not taking advantage of computer vision. And there's been some pretty big advancements that have happened in computer vision over the last couple of years too. So let's take advantage of those things. Let's do those. Those are predictive models. We can build predictive quality models that can predict what the final quality of a batch is going to be well before you ever send a sample to the lab. And I've got examples. We can talk about case studies, but let me go to the next one then. The next category, and the one that I think is really revolutionary, is autonomous AI. And so what autonomous AI is it's built on deep reinforcement learning. So if you remember from 2016, about a decade ago, there was that DeepMind spinoff from Google, and they built AlphaGo, and it was playing Go, and then they built AlphaZero, which pplayed chess. I don't know if you remember all this.
Oh
And it was
yeah,
beating
good
all of
stuff.
our,
Yeah.
yeah, all of our grandmasters at these games. Well, that was deep reinforcement learning. That was the insight. That was the innovation that came out of DeepMind. Well, it didn't go away. And so it started to be, over time, it started to be applied more and more in the industrial space. And so we started to adopt it here at RoviSys, and we really see autonomous AI we think as the inflection point for manufacturing. We think when you look back, it won't be generative AI. It'll be the adoption of autonomous AI that will be that inflection point. Why? Because it can run under constraints. It's deterministic. So given the same inputs, 100 times out of 100, it'll give you the exact same outputs. And it's been proven to outperform some of these older technologies like MPC. So it can do everything that MPC can do, but then it can do things that you can't possibly use MPC for, like production scheduling. And so it can outperform things like linear optimization and linear programming. Existing things that have been around for a long time, autonomous AI built on deep reinforcement learning, has been shown to be able to outperform those. So that's the second category. The last category, the third one, is that generative AI. And obviously that's where all the hype is, and that's where all the investment is. The challenge with generative AI is it's not appropriate to use on the plant floor. You can't use a technology that hallucinates. You can't use a technology that's not deterministic on the plant floor, right? And you can't use a technology that doesn't understand causal connections, which generative AI doesn't. So generative AI does not understand the simple concepts of if then. It doesn't understand if I do this, then I'll get that. It really is these are language-based models, which is fine. but they're not rigorous like mathematical reasoning models. And
I'm going to say it's
that's a big distinction.
textual based and it's based on probability.
Exactly.
So you nailed it right there.
Yeah. So those are the three types of AI. Most customers, when I sit down with them, they think I'm going to come in and talk to them about generative AI because that's what's in the news and that's all the hype and that's what they've been hearing about. And then I have to quickly pivot. I go, that's actually not what we're talking about because it's not appropriate to put on the plant floor. And then we have to pivot and then we talk about the traditional AI and we talk about the autonomous AI as these are the technologies that we use on the plant floor.
So some of the travels I've done this year, this calendar year, the best application of generative AI I've seen are in PLM, product lifecycle management,
Hmm.
basically taking all the data from CAD and requirements data. So it's all
Yep.
text-based. The CAD goes into text eventually. I don't want to go too far. But anyway, and so you can use it for searching out, like going through the requirements documents that in a big company, say a huge airline or something,
Hmm.
there's just so many thousands of pages and so much stuff that it'll do that. But
Hmm.
the area you're in, the area I came from, which is actually making stuff, that's not probabilistic. I don't want like 8 times out of 10 I could put this part together. So that kind of stuff.
That's exactly right.
So
And what
I was gonna say you were gonna go ahead, but I was gonna say, we go back to the autonomous then and kind of drill into the real world kind of stuff? Because in the end, you have to answer to your customer, like, why
Mhm.
do this? And what problem does it solve for me? And what benefits do I get? And that's what really, you know, gets into my heart. So
Right.
if you could, yeah,
Right.
keep going into that, that would be great.
Yeah. So and to circle back real quick on the PLM example, because that's a great example. So you can use generative AI to solve knowledge problems within a manufacturing company, but those knowledge problems, you're typically solving them in the carpeted space, and that's fine. But on the plant floor, we face operational problems, and operational problems you can't solve with generative AI. I mean, again, it's the wrong tool. Like it's a hammer, not a screwdriver kind of situation, and you can't use it to solve the types of problems that we face on the plant floor. So I always tell people use it in your PLM. That's a great example. Use it to dig through decades of documents and stuff. That's fine. I'm not saying a manufacturer can't touch generative AI. Those are great problems to solve with that, but that's not running a plant. That's not what set point do I need at the next moment in my PLC. And those are the types of things that these other types of AI can do. So let me give you an example. So in the case of autonomous AI, so again, this is the deep reinforcement learning. Deep reinforcement learning, remember, it beat our best grandmasters at these really complex games, Go, chess. These are difficult games with crazy state spaces. And you have human grandmasters that have developed strategies over, in some cases, centuries have been passed down. And you have deep reinforcement learning that was simply given the rules of the game and nothing else. It was allowed to play against itself and it was able to outperform our best humans at these tasks. So it's been shown to be able to do superhuman capabilities at some of these tasks. Well, we can apply the same thing on the plant floor. And so we did that. So we've got a customer that makes glass bottles. And the problem they were facing is they had developed a new process for making glass bottles. Now, the glass bottle manufacturing process hasn't changed all that much in about 100 years, right? So this was a pretty big deal. They had come up with this new process, and they had new furnace and new, most of the process had changed. And so the problem that they were facing was they said everything works, but we need an expert level operator to be able to get good results out of this. When we put a novice operator on this, very quickly the process drifts and we're making off-spec bottles. So we're making scrap. We got to throw these bottles away. And so they said that we can't scale this technology if every plant is going to have a 25-year operator, and especially now because the number one issue that we're seeing from manufacturers is the loss of expertise. As primarily baby boomers retire, as folks leave the workforce, we're losing all that expertise. And so they're like, we can't possibly scale this out if we have to have a 25-year operator. So they came to us looking to try to solve that problem. And so what we did was we took their historical data, and with that, we created what's called a data-driven model. So this is a simulation of the real world built on real world data. With that data-driven model, we were then able to hook up this deep reinforcement learning tool, and we were able to train that model on that AI. We called it an AI agent, and then of course that term's gotten co-opted too. But we were able to train an AI agent on that data-driven model. And so within that, it's able to play safely. And so the agent will make all kinds of crazy moves, but it's learning the entire time. It's learning what works and what doesn't. And by the time it's done training, it's like it's a 20-year operator. And so that AI agent then is able to create set point recommendations so that even a novice operator can operate that part of the line as if they were an expert. And so when we put it into production, what that looks like is, and now there is a human in the loop on this, and that's important, right? Because understanding when it's appropriate to take the human out of the loop and when it's still necessary to keep the human in the loop is an important distinction. And when you're talking about automating and using AI, so there's a human in the loop. So basically, what that looks like is that and the customer asked us just put it right on the HMI. So on the HMI, it says here's the set point as it exists today. Here's the recommendation from the autonomous AI agent. And then underneath there is a green button and a red button. And the operator, if they hit the green button, it pushes the agent's recommendation over, and we record that they took that. If they hit the red button, it pops up a dialog and says, well, you didn't take that. And they'll go, well, the agent thought we were in this state, but we're actually in this state, right? And then we use that to retrain and to make it better. But that's effectively what this thing is doing. And the beauty of it is that it took them traditionally 7 minutes to 20 minutes to get back to making on-spec bottles after this process drifted, right? It was very difficult. It was a very hard to control process. And once it drifted, it was really hard to get it back to making good bottles. And so it takes 7 to 20 minutes for a human. Our autonomous AI agent never took longer than 5 minutes, and on average takes 2 minutes to get back to making on-spec bottles after the process drifts. And if you're taking every command that it's giving you, it will actually never drift. But if the humans take over for a while and then they ask the agent to bring them back, it only takes the agent on average 2 minutes to get back to making on-spec bottles. So that was a huge win, I mean, for this company, and it allowed them then to take on the process of scaling this technology out to other plants because they knew that they had this kind of autopilot moving with the system, going with the system, so that even a novice operator could get good results operating this process with this autonomous AI agent.
That works pretty good. Not my area of expertise. I wasn't in that part of automation, but my understanding of model predictive control way back, oh, a long time ago actually. But so the engineers, the experienced engineers would set it up, and it's running, and the plant manager says, "Oh, good. Well, it's running, so we'll lay you off, and we'll hire somebody right out of college, and they'll just keep it running." But the trouble was drift that
Yeah.
these things, just by the nature of math.
Hmm.
One of my first jobs in engineering, the senior guy said, "Gary, you can't violate the laws of physics." So, yeah, kind of that idea. So, yeah, so it sounds like this is a technology. I keep saying this is just, I've been in automation since the early 80s. And I keep saying this is like an automation tool, but every iteration gets better and better. So it sounds like you've gone another level up,
And that's
which is
it.
good. That's the idea, because we're going to have to
Right.
make more stuff with fewer people,
Yeah,
right?
I mean that's exactly it. That's the message is that, and I get a question a lot about like, are we putting people out of work or whatever? It's like, no, these manufacturers can't find enough people. Like there's a labor shortfall right now in the United States of last I heard this was a couple years ago, but it was a 500,000 labor shortfall, and I think it's actually gone up since then. And so like we have all these goals to onshore, and I'm all for that, right? Like I want to see US manufacturing come back to the States. The problem is that our folks don't want to do this. They don't want to do these jobs. And so these clients are saying, look, my clients are saying, look, I mean, we need to scale up, but there's not enough people. So that's where they then look to autonomous AI. And like you said, thinking about it as just an evolutionary step from the existing technologies we've had, like advanced process control, MPC, like that is the right way to think about it. It is more capable, yes. In what ways is it more capable? So this is what I typically say, the analogy when people talk about MPC versus autonomous AI. So I typically say you can think of MPC as like autopilot in a plane. So if you give it a destination, NPC is very good at getting to that destination. And even in the face of crosswinds and things like that and turbulence, as long as within its operating parameters, NPC can typically get you there, right? But what NPC is not going to do is it's not going to say, hey, we need to divert from Chicago to Cleveland. That's a human level decision. That's a pilot level decision. That's what autonomous AI can do. It can make those human level decisions. So it's able to work itself out of problems that other technologies, optimization technologies, would just throw up their arms and say, look, I don't have any idea. Autonomous AI can actually work through those and make human-like decisions. And again, I come back to, if that sounds like science fiction, that sounds outside of the realm of capability. Remember, it beat all of our best grandmasters at these games, at chess, these complicated games. And so when you think about the strategies that our best grandmasters were able to throw at this software, it was these guys, their ego was on the line. So our best, it played AlphaGo played a grandmaster at the game of Go called Lee Sedol in 2016. And AlphaGo beat Lee Sedol 4-1. Now you know that Lee Sedol was throwing everything he could at that thing because he didn't want to lose to this program, and it was still able to. So one of the things that's unique about deep reinforcement learning is its ability to find a solution even in the face of novel problems. So it can actually generalize, not infinitely, but it can generalize and say, this is similar to a problem I know how to solve. I think I'm going to go ahead and try this strategy. And in many cases that actually, and that's the same way humans solve problems, but in many cases that actually will work. And so it's very, very capable. But like you said, it's the next evolution. That's what it is.
So why don't we? I'm going to throw you a curveball that was on my little outline here,
Sure.
but I'm interested in probing this a little bit deeper because we've got tools, and you're talking about tools, and your company has set up a way to bring that out to customers,
Hmm.
and we talked about your one client. So let's step back and say if somebody's looking at this and maybe they're skeptical, which actually they should be,
Yeah, it should be.
you always should. You should always ask
Yeah.
questions. So you're walking into a new prospect or client, something. How are you going to approach? Who do you work with? When I founded, I was a co-founder of a magazine and called Automation World, and my editorial stance was about the team. So there's a team like the vendor, like whoever your software vendor is, you integrate an integrator like you and a customer that actually has to get something done.
Right.
And that's like a team. So I'm just curious, as you're talking about all this technology and put together your team, how do you approach it with like a new prospect, a new client? What would they expect when you come in and you have your initial conversations? Uh, who probes on what problem we're solving. I'm really big on
Yeah.
that.
Yeah,
So I'm just curious about how you approach that.
for sure.
Just
Yeah.
to a little comfort level for the person that reads this stuff and they think it's weird. So
Yeah. Well, and we usually talk about it more as a triad even. So you've got the customer, you've got us as the integrator, but then you have the technology. You have typically a vendor. So those three folks are all at the table and we all have to work together. And we all, like you said, we got to solve a real problem. We got to build a real solution that's going to solve a problem for that customer. Um, so how do we start with the customer? So typically we have a series of discovery meetings with the customer. And part of that is we're trying to get at, the customer will oftentimes throw problems at us that are where AI is actually not the best fit. And I don't blame them. Like I think about this every day. They're not thinking about it every day, right? So we try to guide them towards give us the problems where in the past you've typically had to throw humans at the problem. You haven't been able to use any existing technology to solve that. Give us the problems where it's as much of an art as it is a science.
hmm,
One of the ways I describe it to customers, I go, what is the part of your process where the skill level of the operator has a material impact on the final quality of the output, right? Because a lot of people misunderstand modern manufacturing and they think it's just robots that do everything. And the reality of it is, especially in the US, a lot of our manufacturing is still based on the skill level of the operator. Whether or not you make scrap for that shift, or if you make good high quality product, it's still very dependent on the skill level of the operator. And so that's that expertise gap that we keep coming back to. So I say, where are those places where you've lost that expertise and now you're just scrambling to make product and you're not even hitting your quality targets because, again, you've lost those skilled experts. With those places, those are the areas that we then dial into, because those are the areas that we know AI can make a huge impact. As far as how do we get people to trust the process and how do we get people to buy in, AI is still like, if a customer asks me to guarantee this or guarantee that, I never will make that promise, right? Because there's too many things that are outside of my control.
Right.
But what I can do is I can promise you that I will de-risk this project as much as humanly possible. So the very first thing we do is we get all of the customer's data and we do what's called an exploratory data analysis, an EDA. And that EDA is where we actually go in and we do that data science and we do some preliminary model building and we ensure that there's not gaps in the data, that we don't have dirty data, that we don't have issues where there's missing data. Sometimes we'll find that it's like, look, we want to do this project, but there's one key piece of data that you haven't been recording. And that's the key, that's the linchpin, everything, or a lot of times, these projects, you need not just the process data, but you need the quality data, because that's typically what you're aiming for, is the quality. And that quality data, boy, I'm finding out that all the modernization that we've done over the years around process data with historians and stuff, that didn't happen in the quality labs.
No.
The lens systems oftentimes are glorified Excel spreadsheets or Access databases. So, or just still like quality labs, just still operating on paper. I mean, I've got a big customer right now, and they are still operating on paper in their quality lab. So then you've got a whole separate project that's kind of upstream of the AI project you got to do, where you digitize the quality lab so that you can even get access to the data so that you can do any of this AI. And so there's a whole AI readiness aspect to this, but let's assume that they have the data from the quality lab. So now we're able to marry that all together. And now we're able to do some preliminary analysis. Then we sit down at the end of the exploratory data analysis and we have a go, no go meeting. And we say, this is everything we found. We either say, hey, you got these key pieces of data that are missing. Here's a small project we'll propose where we'll add those data points in. Or we say, look, you have everything you need. And here's all the data to prove it. Here's the charts and graphs. And we make sure everyone around the table is nodding yes. Yep, we've proven our case. And then we can move on to the next step. But it's a very deliberate step-by-step approach to try to de-risk these projects as much as humanly possible.
Uh, Thank you. That's a good introduction to as we leave the technology and go into the practical aspects, how are we actually going to do this and make people feel a little bit calmer? And you're exactly right. The right tool, I think we started out the right tool for the right thing.
Yeah,
And it's like, don't just throw AI at it. There was some joke somewhere about, I want some of this here AI stuff.
right.
No, no,
Right.
no, no. It's what tool do you need and so on. And I'm kind of eyeballing my time up here, and I'm thinking we're getting ready to close. And I think this has really been a great conversation, and I think a lot of people should enjoy it because we're taking the hype out of AI and bringing it down to the factory floor into reality.
That's
And
it. That's right.
I've seen it just from my perspective out here. So it's really useful and it's usable. And I appreciate your being here, Bryan. Like I say, I almost never do these, and conversations are enjoyable. Uh, and I should get some information like we talked about RoviSys, talk about you know how to contact you. I mean, I'll put stuff in the show notes, of course, but a little bit about how to contact you, the company, that sort of thing.
Yeah, so it's real easy. RoviSys.com, ROV as in Victor, ISYS, RoviSys.com. Or look me up on LinkedIn. It's Bryan DeBois, and you'll find me on LinkedIn if you just search for my name. And happy to connect with folks. I do speak pretty frequently at trade shows about all this stuff. This is probably my 38th or 39th podcast appearance on various manufacturing podcasts. So, and all of those podcasts are up on the RoviSys website, all those appearances. So yeah, happy to talk to folks about this. I'm very passionate about it. I think that, like I said, if we're going to bring back US manufacturing, AI's got to be part of the story. It's not the whole part, it's not the whole story, but it's got to be part of that story. And I'm always excited to talk to folks about it.
You're exactly right. I'm staring. If I could stare through my wall, I would see my neighbor's house. He owns a company. He can't hire enough welders. He is just going crazy trying to
Yeah.
keep his company going. You're exactly right. Hey, I really appreciate it. Appreciate the time. To get into some of these conversations. Never know where they'll go, and it's really cool. And hopefully we'll connect later. And once again, this is Gary Minchell, and you've been listening to my Gary on Manufacturing podcast. And I'm sponsored by Inductive Automation. And go check out inductiveautomation.com and check out their product Ignition, which is it's a really cool product. I've been involved in software a long time, and they just blow my mind with the new things that they come up with and new tools to give people like integrators to do their job. So thanks for listening, and as always, just go out and be kind to the next people that you meet. And thanks for listening.